If you're old like me, you remember the days where new tech was revealed almost exclusively as a talk at a big conference. These talks were the thing that we were all so hyped about. We'd go to the conference just to see the keynote, see what was revealed, try to talk to the people who built it, and then watch videos about it afterwards. One of my biggest inspirations for starting YouTube was the fact that the talks had kind of dried up during COVID, and there weren't many things like it being posted. I wanted good senior YouTube content. Now the whole tide has turned. When new things come out, they're not coming out at a talk at a conference. They're coming out with a tweet on random websites. The whole dynamic here has shifted so much. But I want to take some time to go back. Want to go back to a talk that changed everything. A talk I think about probably far too often considering that it's 11 years old. But this is a very important talk. Rethinking best practices. Funny enough, also inspired by a tweet, but yeah, this talk is nuts. There is so much we can learn from it here. This is the talk that made us take React more seriously, and it really, in my opinion, ushered in the new web. When you think about it, it's kind of crazy that one talk could just drop and change everything the way this did, especially considering that it's a free resource for an open source thing. But in order for me to keep my resources free, we do have to pay the team. So a quick word from our sponsor, then we'll get straight to it. Wouldn't it be cool to see your brand in a video like this one? I think so. That's why I take sponsors. We now have a wonderful wide variety of companies that we show to my audience of hundreds of thousands of experienced app developers, AI, web, and whatnot. The coolest part? My audience likes the sponsorships. Yes, really. Here's a bunch of comments of them saying just how much they like it, and you can read way more on our website too. There are a few better ways to show your product to a super technical audience. So if you're the founder of a company trying to get in front of these devs, you're a marketer trying to figure out how this whole space works, or you're a person that watches my videos that thinks your business should be in front of more people like you should hit us up. You might be surprised how cheap it is. Email us today at youtube@t3.gg. We're running low on space, so hit us up fast. Oh, and if you're a YC company, we do discounts. Anyways, back to whatever that nerd was talking about. Before we get too deep in this talk, I want to set the stage. At the time, the most popular solutions for building your new web apps were two beloved tools. jQuery, and the real fun one, Ember. jQuery was the solution for you'd write your HTML, you would bind things in the HTML to JS via jQuery for targeting, selecting elements and whatnot, and create your Ajax experience through jQuery. Ember was trying a more direct approach where the JS had more ownership and control over the UI, but the relationship and the binding between the two was most of the code you were writing. Is how does the HTML get updated? How does all of this get processed? All of that. Angular was starting to gain some momentum at the time. And as a certain Naman hanging out in chat is pointing out, thank you, by the way, Backbone was doing pretty well. Okay, Ember wasn't that big yet. I have the bias of like the communities I was in were all Ember obsessed. So I take your word over mine. I wasn't in the industry yet. I was just learning this shit for fun on the side, but I'll re-rank these accordingly. It's my gut feel that Ember was at least more popular than Backbone. Backbone was like the nerds solution. But for what it's worth, some fun facts here. You guys know who Ryan Florence is? One of the creators of React Router. He was deep on the Ember community at the time. And the reason he moved off of Ember might surprise you. We'll get to that in a little bit. But this was the options we were picking before. And don't forget the good old mean stack. Mongo, Express, Angular, and Node. I'm thankful that the right one of those four technologies survived. Eventually mean became Mern, and the world became React. But we have to talk about how we got there. Because the initial launch and announcement of React was not received very well. 2013. React, a JavaScript library for building user interfaces. First impression is that it looks like a PHP language extension. Be nice to see a list of reasons one might choose this over Angular or any other frameworks. The features in the description on the homepage are vague. Consider the architecture difference of React and other similar view model frameworks. Similar to the difference between Git and SVN. This is actually particularly funny because if you don't know, Facebook doesn't use Git. They use a stack diff model on top of Mercurial. Other view model frameworks typically track all changes to the view model by explicitly firing an event for every delta change. That in turn causes another delta and so on. Here's a pretty bog standard React component. We've all, hopefully, if you're watching this, seen code like this in the past. The important thing to note here is that there is no bindings to events or code that manually updates the DOM. Here, well, let's ask T3 chat quick. Rewrite this example React component in original 1.0 Angular JS code. So this is the difference I want to make sure we highlight and understand. In something like Angular, you wouldn't define a component that has a value that then gets rendered. You have to define the behaviors through things like controllers. This controller has a scope of count, and it also has an onClick function in the scope. And then we direct that to this counter element that now has these properties. And it's the ngClick property of onClick. It renders the count. Even this is still a little more declarative than what you would get from other tools at the time. So let's tell it to rewrite this in jQuery. This one will be fun because it has to do actual HTML for it. We embed our script tag. We create the button. We don't actually append it yet though. So we've created this button. It doesn't exist in the DOM. We just have a button element floating around. It has text, which is count. On click, count plus plus, this.text count. So we have to manually increment the count and then manually update the content. But we still haven't even rendered it. We have to then afterwards append this to the DOM to render it. Obviously, Angular was an improvement here, but it still wasn't properly declarative in the sense that we're used to nowadays. I have been asked to do Backbone. Interesting. Yeah, so Backbone, a little more similar to React. We have the model, we have the view, and then we create it in the UI here. We create the counter model, we create the counter view, bind it to that model, and then append it to the body. But these are the details that matter, is we have to create the relationship between the view and the model, and then we have to bind it to the UI ourselves. All of these are our concerns, and the result is your concerns are, sure, really effectively separated, but this is all one concern. The counter going up, and the counter being rendered are, in my opinion, the same concern. Being forced to separate it this way between model, view, and sometimes even controllers sucked, but it was best practice. So this is what we were all expected to do because it's the best practices, it's the clean code, it's all those things. And when React came out, it meaningfully challenged that, and a lot of people were upset. In particular, a lot of people were upset about JSX and the introduction of this HTML style syntax in the code. They were not happy. A lot of people would even say, like, I kind of like what they're doing here, but the JSX thing sucks. No one's ever going to want to use that. I'm confused. Every example is 100 times the code I would write using straight HTML. Is there a benefit I'm missing? Yeah, this is the problem. It's also worth noting, if we look at these older examples, that a lot of the code we would write would just be in the HTML, and we would use these MVC parts to make certain pieces dynamic. It was still a kind of new idea to build the whole UI with your framework. Traditionally, you would just build the interactive parts with the framework and build the rest with your HTML templating from Ruby or whatever. This talk changed all of that. And I hope that this context helps you realize where we were at this time. React was challenging the norm in a way that people weren't accepting of. And the way that people framed it was, oh, they're just doing it wrong. Everyone else is following best practices. React is rejecting them. React isn't following best practices. Pete reframed it as rethinking. Let's hear what he has to say.
I'm going to talk to you about a library for creating user interfaces that we call React. And we open sourced this at JSConf US a couple months ago. And we got some kind of sarcastic responses on Twitter, a little bit of snickering, that kind of thing. We weren't really communicating what we were doing. So I'd like to talk to you today about the design decisions around React, what we're doing differently than other frameworks, and kind of the implementation that lets us make these decisions and make it really fast. So it's not a tutorial. It's not an introduction. You're not going to learn how to build React apps today. But you might be able to use some of the stuff that we've discovered in your own work. So I ask that you please just give it 5 minutes. Some of the stuff that I'm going to say flies in the face of some established best practices. But we found that there are certain best practices that deserve to be challenged.
Legendary post, by the way. It's a post from 2012. Give it 5 minutes. It used to be a hothead. Whenever anyone said anything, I'd think of a way to disagree. I'd push back hard if something didn't fit my worldview. I wonder if this was written for a certain coworker of his. Yeah. The main point here is, if you take the time to just think about something for 5 minutes instead of react to it immediately, you might think very differently than you were initially. It's funny to see a quote from the Rails world and a blog post from that world especially coming in here, but I think it does actually make a lot of sense. If you're so ingrained in these best practices, if you're so ingrained in SQL only goes on the server and you can't pass things into it, if you're so ingrained in React only exists on the client, all these things, and you're too busy reacting to the thing to think about it, you'll never meaningfully progress. And it's sad that this reactionary culture has become so strong. It's even sad to think I might have contributed in some ways, but it really is important to sit with the idea and digest it a bit before you take your stance on it. And don't worry, I've thought about Flutter for a lot more than 5 minutes. Anyways.
So meet React. It's a library for creating user interfaces. Specifically, we render your UI, and we respond to events. A lot of people think of us as the V in MVC. Maybe we're the controller too. Really depends on how you use it.
What React actually is, and they could not have realized at the time, React was the end of MVC. It just took us 10 years to accept it. Even other frameworks are beginning to regret the bet they made on MVC. I'm not convinced Laravel would be an MVC framework if it was made today.
But we try to play nicely with your stack, whatever it may be. So for example,
this one's funny amidst the Vite drama, but the rest of this holds up really well.
We're not opinionated about how you fetch data. People use us with Backbone or whatever you use for managing your data client side. So I'm going to talk to you about kind of the initial principles behind React, which is all about building components. Then I'm going to talk about the design decisions that we made that make React a little bit different from other frameworks. And finally, I'm going to talk about the implementation and how we're able to make our implementation of this framework really, really fast. So I'm going to start with building components, not templates. If you want to think about this cynically, we're talking about mixing markup and display logic. And a lot of people completely disagree with that.
Oh man, markup and display logic, those should never ever touch. That's such a bad idea. Who would ever, oh, that's what we all do now, isn't it? Huh. Starting to see where we're going here?
So this is, I'm not sure if you can read it, but this is kind of what React code looks like. This is from our to-do list example on the homepage.
Good old class components. What's funny is this code will still run today if you use the create class helper that they posted. You can actually run this code on the server. I did that for a video a while back.
It's all about building reusable components that know how to render themselves into the DOM.
And if you're seeing that react.dom part here, this was pre-JSX. So instead of calling div with a tag, react.dom.div. First argument is null. That's the properties you're passing it. So this would be like a class name or whatever. React.dom.h3, also not getting any custom properties, but it has a child of to-do. To-do list actually does get custom properties. This is its own component. Gets this.state.items. And then we have another child here, React.dom form, which is just a form tag on submit this.handles. You get the idea.
But like I said, I'm not going to go through this line by line because this is not a tutorial. This is about design decisions. But we all like separation of concerns, right? This has kind of been a fundamental tenet of building apps on the web ever since like the PHP apocalypse of 1999, where we were putting MySQL fetch row in the middle of our table rendering code.
Yeah, I'm sure that we would never make that mistake again of calling SQL directly in our components. That's not a thing we would do in React. Definitely not.
But let's talk about what separation of concerns actually means. We're talking about reducing coupling and increasing cohesion. Coupling and cohesion, they're two very important principles of software engineering. Here's the definition I pulled off of Wikipedia about coupling, and it's the degree to which program modules rely on each of the other modules. Now, that's kind of like a fluffy definition, but more concretely, if you want to implement a feature or fix a bug, and you make a change to one module, be it like a class, CommonJS module, function, a packet of functionality, how often do you have to go to other parts of your code base and make changes in order for it to work? And these sorts of cascading changes are symptoms of coupling, and that's what makes software hard to maintain.
I agree with this so hard. It's actually unbelievable. My research team is concerned that me showing this might make people concerned. This isn't insecure. This using a tag template literal here. So we're not just blindly passing slug in. SQL here is a function. Its first argument is this string, and the second argument is an array of things that get stuffed in at those points with additional checking. So this is safe, even if your gut when you look at it is that it is not. This isn't just a string being passed to SQL. This is being called as a function where all of the components are different arguments. So the SQL function can safely parse it. So don't go nuts looking at this and be like, oh, it's so insecure. Your own insecurity is showing. Thank you, Gabriel, for making sure I make that disclaimer. Anyways, I have so many thoughts on this coupling bit. I'm going to let Pete talk a little more, but then we're going back to diagrams. I have a lot to say.
Cohesion is somewhat related as well. And that's the degree to which elements of a module belong together. So if you've heard of the single responsibility principle, basically grouping related functionality into modules and not putting extra crap in there. Kind of the litmus test is like, does this class make sense, or does this function make sense, or is it doing a lot of stuff, and can you refactor it into other pieces? So I think that templates encourage a poor separation of concerns. And it's not just templates specifically. It's anything that tries to augment the DOM or HTML with some sort of functionality to make it better at building apps. So I think Angular directives also fall into this. And it's not just client-side either. It's some server-side systems as well, like Jinja and kind of traditional templating solutions. Now, how can I possibly make the argument that this is a bad separation of concerns, right? You've got your display code in one place, like your template, and you have other code in other places that do different things. Now, normally, your controller and your template are tied together with something called a view model. And some frameworks, actually, the controller is almost the view model. So you pull some data out of your database or with like an AJAX call or something, and you construct a data structure that looks something like this. So if I wanted to show a product grid with the example that everyone uses, which is alternating row colors, in some templating systems, you have to add a table row color attribute to your view model. And we say that that's fine because it's a view model. It's not the model, and it's not the view. It's a view model. Now, the problem is this tightly couples your controller to your template. So if I want to make a change to how I render those row colors, while it feels like I'm making a change to the template, there's an implicit dependency between the template and the controller because they both agreed on that template row color attribute in my example. So you actually have to make cascading changes throughout your module. So it's not real decoupling. And I think that the display logic and markup are inevitably tightly coupled.
Yes. Just yes. Let's diagram this a little bit. Let's say we have a feature that we are building. Let's say, I don't know, we work at a streaming company called, I don't know, Twitch. You might have heard of it. There's this weird guy, Theo, who used to work there that makes YouTube videos that he films live on Twitch. Don't want to be like him, but Twitch is a thing. It exists. Let's take a look at a given feature on Twitch. Let's think about Twitch chat. Twitch chat has a lot of components to it. I'm going to remove that for now. Let's just think about the individual boxes for each of these parts. First box here, we'll call it the styling. So this is the CSS, maybe CSS and JS, whatever you're doing. The styling is one of the parts of building this feature. There's also the markup, HTML. This is the actual elements on the page that are rendered. There's also the JS logic. And this JS logic determines where the messages go, where to scroll to and from, what gets bound to what, et cetera, et cetera. And this JS connects to a WebSocket. The WebSocket is the thing that pushes down the new messages when they happen. And those come from a service. I'll just call it the backend. The backend is its own crazy complex thing with lots of different layers here. The point being, when a new message comes in, it comes in here, and then has to go through all of these layers before the user can see it. So the message comes in on the back end. Somebody hits an API that makes a new message. It gets sent down the WebSocket. The JS receives it, updates the HTML. The styling applies to that HTML, and now the user can see it. Now let's build another feature. Let's say the Twitch sub tracker, or I'll just say sub alerts. Sub alerts are the thing that happen when someone subscribes on Twitch. So whenever somebody subs and they're dropping money to support me and the team, these little alerts pop up here. Sure, UI-wise, these actually look quite a bit similar, but it's not just the UI where they're similar. Sub alerts, they need to have styling. They need to have markup. They need to have JS logic. They need to come down via a WebSocket. And believe it or not, they also need a backend of some form. When you look at this, you might think, oh, yeah, if all of these features have the same boxes in them, we should just separate our app accordingly. We're going to break it up by all these different layers, because all of these are their own problem. We should separate them accordingly. We should have the style stuff all live by itself. We should have the markup all live by itself, JS, WebSocket, backend. Now it's very clear when you're in the backend world versus when you're in the styling world. This was a mistake. Anyone who defends building this way is either bad faith or a bad dev. This was wrong, because adding a new type of message to Twitch chat means I have to now go touch all of these layers. I have to spend a whole bunch of time making one change in each of these layers. And chances are these layers aren't just layers. These are all their own teams. So I have to get my change approved by the backend team. I have to get my change approved by the this might still be the backend team, but it's probably a services team. This is probably more like DevOps type stuff that I have to get the JS logic approved by whoever's in charge of the web bundler and build team. Then I have to get the markup approved by who the fuck knows. Nobody believes HTML is a real language, so whatever. And this is owned by design, so design eng. Now, whenever I make a change, I either need to get all of these people to go do the thing, or I have to go do all of it myself and get them to approve it. This is bad. This is dumb. The way things work now, and pretty much every company has moved this way, and to Facebook's credit, they were very early with this. They separated things entirely differently. The separation at Facebook is like this. Obviously, there are things shared on different layers. Not going to pretend otherwise. But the feature owns all of its code. Instead of having 5 different files for the one feature all living in different systems, sometimes in different repositories and code bases entirely, they do their best to get all of the concerns in their own box so that when I'm changing Twitch chat, I'm changing the Twitch chat code. I'm not changing the backend code, the WebSocket code, the JS markup styling. I'm changing the code for Twitch chat. And this makes so much more sense too, because when there's a bug, you just look at the vertical that the bug exists in, and you'll almost certainly find it. When you're adding a feature, you live in this box, and it's going to go much better. The only reason this model works is if your team or company is small enough that everyone on each of these layers knows each other well, or maybe the same person is these 3 layers. That's fine. But as these code bases get more complex, horrible things start to happen. Like someone makes a change to the backend for sub-alerts, and somehow this breaks it over here and then propagates up, and now your UI in Twitch chat is broken because someone had a bad assumption on how the backend for a different feature should work. And this was just life in separation of concerns. If your concerns are separated by technology, not by feature, a tech change can break your feature. An unrelated tech change can break your feature. And this is unmaintainable, because what ends up happening is crazy relationships get built between all of these things. The WebSocket layer for Twitch chat gets used for the markup and sub-alerts. The styling for Twitch chat gets used in the markup for sub-alerts too. The markup for sub-alerts might get used in the styling for Twitch chat as well, because it sometimes renders those there. The backend here might change the templating for something else over here. These horrifying bindings between the two are where the work ends up being, because once you've drawn all of these lines separating the shit, you've made it harder to go over them. You've made it harder to go from one layer to another. Now I have to look at 8 different files just to make Twitch chat appear the right color. It's hell. This is also why technologies like Tailwind won, because I don't have to hop across a barrier to see the styles and see how things are working in my component. This style of separation is a dying, I guess, I was going to instinctively call it a dying art, but that implies that there is some artistic merit to it. There is no merit to this way of design. There's a reason the people who are really big on this don't write code anymore and just write books complaining about how we're all wrong. There's a reason that a 70-something-year-old dude loves to tweet Shrek GIFs at me instead of writing real software. Oh, Bob. Anyways, thankful as always for Meta, Facebook at the time, for being willing to challenge these best practices, because a real company quickly realized that they don't scale for shit.
So if you're building apps on the web that manipulate the DOM, you have to figure out where in the DOM you're going to change, and what parts need to be updated, and what nodes are receiving events. But the good news is that this is highly cohesive logic. So the JavaScript code that drives your UI and the markup that displays it to the user are both doing basically the same thing. They're handling user events, and they're rendering data to the user. So I would like to argue that templates separate technologies and not concerns. It's not a real separation of concerns. It's a separation of technologies you're using to implement the same concern. And unfortunately, the way that we're doing this today, they tend to be deliberately underpowered. So I'm going to show you a couple of examples of what I mean by being underpowered. And the first technology I'm going to pick on is handlebars. Sorry, Tom. So first of all, handlebars is an excellent implementation of templating. It's really fast, it's really easy to understand, and it drops right into a lot of different frameworks. But it's an implementation of kind of a classical way you build templates. So the abstractions you have available are fairly primitive. So the easiest one to think of is partials. If you want to reuse a template, you tend to use partials. And a partial basically takes one template and embeds it in another template. Now that embedding puts that template in the parent's scope. So if you want to make a change to a child template or a partial, you need to track down every single call site that uses that template and make sure that you don't break anything, because there isn't a strict contract between the partial and the template that includes it. This is going to be a recurring theme of my talk. Another example of an underpowered technology in here is each. It's like doing functional programming, but you only have map. You don't have filter. You don't have reduce. It's hard to do branching. And frameworks have...
This is funny because this is still going on to this day, where we have new things like Svelte and Solid introducing custom elements to do things like mapping and for eaches in the markup. Because these are concerns of the logic more so than the UI in the traditional sense. Like the number of items in the list isn't a thing that should be your HTML's problem. That's a JS problem. That's a problem in the thing that's providing the values that you're rendering in the list.
Solved some of these problems that I've mentioned, but they're kind of hacking around the idea that we want to pull certain parts of our display logic apart and artificially separate technologies. Another symptom is if you're continually inventing new concepts. So JavaScript is based on a rich history of von Neumann-based programming programming languages, and has kind of battle-tested philosophies, right? Like,
did you find the meme that fast? Goddamn dumb. Yeah, this classic. In JSX, it is JavaScript minus the HTML part. Condition, content, other condition, other content, fallback. I even prefer to make this a function. And if condition, return content. If other condition, return other content. Bottom out, return fallback. Svelte, its own thing. Vue, yeah. Oh, Vue.
We understand how functions work. It's very clear. Prototypical inheritance, most people understand. But when you start to build abstractions on top of HTML, you start to have to invent a lot of things in order to get to the level of expressiveness you need to build real applications. So now I'm going to pick on Angular. And I just pulled this quote out from the Angular docs, and I've highlighted every concept that they've created that I'm either not really sure what it means as a new user of Angular, or it sort of exists in JavaScript. And it's based on the idea that they want to augment HTML to support two-way data binding. And in order to do that, you have to rethink the idea of scopes. And if you rethink the idea of scopes, you have to rethink the idea of composability and modularity. And you start building directives and transclusion and all this other stuff.
I don't recall if he makes this exact point, but I will in case he doesn't. If you insist on separation of concerns, you're still going to have to rethink a ton of things. You just have to rethink the technologies themselves. And if we have technologies that we understand that are relatively good, and those are running against what we know as best practices, why are we hacking the technologies to match best practices, when instead we could throw away our arbitrary concept of best practices in order to take advantage of what the technologies are actually good at? That was a revolutionary thought, well beyond the React and web dev world. The idea that our insistence on breaking the tech to follow these arbitrary ideas of clean code was the wrong path. And we needed to go back and rethink how we built these relationships and bindings between our technologies. And he's right. Like the amount of concepts and like words that were invented by Angular to try and communicate these ideas was just kind of insane at the time. It was so hard to get your head around.
But I think the framework cannot know how to separate your concerns for you. It should only provide powerful and expressive tools to let you do it. What I mean by that is that a lot of frameworks force you into this MVC style of development. And MVC is great. However, your controllers tend to get really fat, or maybe your models get really fat if that's your style of building, or maybe even your views. The reason for that is the framework is telling you how to separate your components, and the vocabulary you're speaking is that of the framework and not of your application. So we want to change that, and we think the best tool for this is a React component, which is a highly cohesive building block for UIs that's loosely coupled with other components. Coupling and cohesion.
This is the key piece. If we go back to the code here, let's edit this again. I was going to take it and make a new thread here. I'm going to ask it to do it in Angular again. Now render 4 of them. Since they are still separating like this, it's not as bad because we've created this concept of a counter directive that we can then mount multiple of in the UI. But what if we want to share counts between them? When any one count hits 10, reset all of them. Now things start to get a little bit more chaotic. The ng repeat directive. Oh, God. Yeah, like you have to write in the markup these hints to tell it what you want to do. It's kind of chaotic. Yeah, ng repeat counter encounters on. Yeah, God, no. All starts to fall apart fast.
Constant theme here.
The big piece, the thing that like this really drives is when we get rid of this arbitrary idea of separation of concerns, the best reward we get for it is composability. And we're about to go deep on that part.
So we want you to use components to separate your concerns with the full power of JavaScript and not a crippled templating language. So I'm going to pull up that example I showed earlier briefly and just highlight a couple of things. We wanted to reuse some functionality. So in React, we created a function, which is how you reuse functionality in JavaScript.
And they went way further with that with hooks much later on, like 6 years later, which is crazy to think that they were able to have a similar level up with state. I almost want to do a whole separate video, like the forgotten magic of hooks. Like that moment was crazy. Components let us make composable UI where an element could own its own life and be reused and mounted by something on top and know that it won't be screwed with in that way. Then hooks let us do the same for state, which is just so crazy.
We wanted to reuse some code and pass different parameters in each time and have it render to the DOM. So we used composition, and we composed a to-do application out of a to-do list object component. Again, this is just regular JavaScript software engineering principles. And we also have the full expressive power of JavaScript. So, for example, I wanted to add 1 to the length of this list when I render it. I didn't have to jump through any hoops. I just put a JavaScript expression in there. Co-locating your display logic with the logic that generates the markup, that sounds like it's going to be a mess, right?
To be fair, I've seen some messy code that is only possible because of the flexibility of React. But I've also seen messy code that is effectively necessary because of the separation of concerns and other solutions. So yeah.
My answer to that is just don't write spaghetti code. We're software engineers. We can shoot ourselves in the foot, and I'm sure that everybody's taken down something in production before. You can keep your components small because we're trained to do it. We do it all the time with our other JavaScript code. Why can't we do it with our front-end code? Only put display logic in your components. I'm not advocating putting all of your model validation code and fetching and data access in components. You might want to put them in third-party libraries that have some sort of bridge to your components, but only put logic that makes sense in your components. And this
I will say, like, to this day, I think people screw this up. If you were to audit any of my code base, especially like the T3 chat code base, I would guess 80% of function definitions or more aren't components and live outside of components. That's a gut feel guess. I'd have to like actually audit it to be sure. I am very deep in the habit of break out the function, define it, and then call it in the component. Makes everything way more simple. If you try to think of React as the best way to compose the UI and behaviors, but the behaviors themselves are encoded in functions separately, it makes reasoning about your React application way easier. And it's something you can't really do in other frameworks at all.
libraries that have some sort of bridge to your components, but only put logic that makes sense in your components. And this kind of reminds me of that Spider-Man quote that is always repeated at software conferences: with great power comes great responsibility. Another thing that people think about when you're talking about generating DOM in JavaScript is cross-site scripting.
It's another fun point from chat. Something tells you that I would either puke or laugh looking at some of the Angular code you've seen. Almost certainly. I would, God, some of the old Angular code I've looked at has made me question if I even want to be a software engineer.
So a lot of times people do string concatenation to generate markup and then insert that in the DOM. We've created a very lightweight library that we call React DOM to make generating a description of the DOM very easily. This is calling a method called a, which generates a link. You pass your JavaScript object of attributes in, and then a child, which is the second argument. And that can be other React components, other React DOM calls, strings, collections, that kind of thing. And this makes it really safe for us to generate descriptions of the DOM.
This is one of those points I don't think is appreciated enough anymore. Cross-site scripting was a very real problem. So imagine if instead of this being useState, this is use user data. Rename this from count to user data, kill the setter. Then user data is something like, sure, name Joe, age 30. Kill the function there, make a quick div, hello, you are whatever. This all hopefully makes sense to us. Userdata.name, we render it. Userdata.age, cool. What if userdata.name wasn't something like this? What if it was script XSS? Love that they knew what I was doing. If you assume that the people who made React are clueless, you would be fairly assuming that what this will then do is render as HTML in the page that does this. And now we've broken your React app. Now if I update the database to have a script tag in it for my username, I can hack you. Good old Bobby tables. I feel like half my videos nowadays have a relevant XKCD. This is the classic one. Did you really name your son Robert Drop Table Students? Oh yes, little Bobby tables. Well, we've lost the year's student records. I hope you're happy. And I hope you've learned to sanitize your database input. Yeah. So at the time, that sanitization would often happen in the database layer. So we'd make sure we didn't have script tags or SQL or whatever in a state that it could make its way into the data so it could then be rendered, and then this happens. If for some reason you actually want to do this, like userdata.script here, you can, but you have to dangerously set inner HTML. They put a special flag in for this because React won't do it for you. If you really do want to do this, you can. Every other framework, that's just how it behaved, because you would pass it HTML and it would render that HTML. Since this isn't HTML, it looks like it, but it's not. This is the equivalent of React DOM.div, and we're calling it with these elements. Obviously, if we're calling it like a function like this, you would expect this to sanitize whatever it's putting, not just render it as HTML. But JSX, all it is a syntax to call that function. When you do div like this is calling React DOM.div. It's just functions in a different syntax. And this is what's so cool about React is we can use the mental model we already have for HTML and JS. It handles a few edges for us and gives us a composable format to safely write scalable code. It's so cool. And I think especially nowadays as we get more and more frustrated with certain things that happen in the React world, we forget about the magic of what this did. That so many of the problems we were used to dealing with every day just kind of vanished all of a sudden.
Next thing you're thinking about is probably, what about working with designers? We're not the first people to come up with the idea of generating DOM using function calls. But a lot of times it's a little bit cumbersome to work with. We've actually found that if you're just trying to balance parentheses visually, it can be kind of annoying to do that. And also designers tend to not like that.
I will say to this day, designers tend to not like working in React. This kind of goes back to the separations thing earlier. It was very common back in the day for you to have designers who knew CSS that would own this part, and the engineers building the feature would just build the markup in the JS layer, fight the services team to get these parts, and then let the design team take over and actually write the CSS for you. That was how a lot of companies worked, and it was awful.
So we built JSX, which is an optional preprocessor. It's a syntax extension that lets you write code that looks like this and
Kind of funny to label JSX as optional. No one is writing React without it. They did this because the pushback initially to JSX was so absurd that they wanted to make sure they didn't want React to die if JSX was the wrong bet, but JSX was the right bet. It won.
translates it into code that looks like that. And that's all it does. We're not reinventing E4X. There's no runtime that supports this. We're simply taking expressions that look like HTML and turning them into function calls. So you get all the semantics of JavaScript. You get the same line numbers as you would before the transformation. So you can actually run your linting tools on your markup and get all the same rich debugging information that you otherwise would. And with JSX, we've just found that it's very easy for designers to contribute code. I personally don't want to spend hours tweaking the box shadow of all of my elements. I'd like to just have my designer come in there and tweak them for me. And so we've actually found that this is very successful. And we think of it like this. It's the accessibility of templates and the power of JavaScript. The accessibility of templates and the power of JavaScript. You can use all the regular JavaScript code to generate these because they're just function calls, but it looks kind of like markup, so you can go in there and kind of still have your flow. So React is all about components, and it's not about templates, and that's how we want you to separate concerns.
Oh boy, here's where the controversy started. If you want even more info on this one, the React documentary is full of it. This is the key design decision of React. Whenever something changes, the whole app effectively re-renders. And that just sounded impossible. Like, JavaScript's so slow. Why would you ever do that? Why would you check everything? That can't work. And it can't, kind of. But I'm sure Pete helps us understand better in just a sec.
I'm going to talk to you about what I think makes React awesome. And the key design decision that makes React awesome is that we basically re-render your entire app on every single data change. We all know that building UIs is hard, and that's because there's so much state. You've got lots of UI elements. Designers can't make up their mind. You ship one version, the A/B test comes back, and you want to ship another one. Crazy environments. If the DOM is up for a long time, you may write to the DOM somewhere and forgot that you wrote there, and then you forgot to keep track of it. And we've identified that data changing over time is the root of all evil.
Yep.
And it's really hard for us as engineers to reason about this. And we're not the first people to think this up. Actually, Dijkstra thought it up first. Our intellectual powers are rather geared to master static relations, and our powers to visualize processes evolving in time are relatively poorly developed. What he's basically saying is that it's really hard for us to think of processes over time, but it's fairly straightforward for us to trace the flow of a program. He continues with, for that reason, we should do our utmost to shorten the conceptual gap between the static program and the dynamic process to make the correspondence between the program and the process as trivial as possible. Now, Dijkstra's advice is that we should take processes that go over time and build abstractions that make them look like programs that execute in a single point of time. And that's what it was like in the 90s. When we were building server-rendered apps, we'd hit the database and we'd render a page. And let's say it's a to-do list example, because that's another theme of this presentation, I guess. You render the list of items in a count, and when you submit another to-do item, you just select from the database again, your count and your list are up to date, and you just refresh the whole page. It's very simple. We don't have any of these problems with data being out of date and stuff. So when the data changes, React does this. React re-renders the entire component.
There's a certain phrasing that has popped up a lot in the React world, changed a bit over time too. I'm gonna just write it out here and see if y'all know what I'm talking about. The UI is a function of state. If you give this function the state, the same UI should always come out. If you change the state, a different UI should come out, rather than each element in the UI relies on another element in another state change that happened somewhere else, and whether or not this happened before the other thing. None of that. You give the function that defines your UI, your state, and out comes the UI. As a functional programming nerd myself, I will die on this hill. This is the only correct way to write software. Everything that does stuff differently either has a really, really good reason and sucks to work in, or it's just wrong. It has to be one or the other. And most of the applications we're building today can be boiled down to this. That's why PHP is having a resurgence, because if we treat our web apps that are mostly CRUD apps, grabbing stuff from a server, the UI is the template being filled out with the data from your database. That's really easy to do and work with. React brought it a layer up so we can treat our ideas and treat our UI in a similar way. What this means is when you call this function with your state, a new state doesn't come out. We don't bring out new states when you call state. We don't bring out changes to other UI elements. This is a single step ordering. Your entire React app becomes a function call that you call with the state, and then it might over time have new states happen, but rather than the state manually binding to some specific element somewhere on the page, the whole page will just change when that state changes.
This basically makes it really easy for you to think about what state your application is in. Said another way, React components are just idempotent functions that describe your UI at any point in time, just like a server-rendered app. Again, because they're just functions that take some parameters and output a description of the UI, they're very easy to unit test. So here's a very brief example. This is a link that I can click, and the count goes up. We've isolated the mutable state in a getInitialState method, and we've isolated all the state transitions in setState methods. And setState is basically how you tell React that the data has changed. And it doesn't matter where your data came from. We've done bindings for Meteor that are 14 lines, bindings for Backbone that are 5 lines, that kind of thing. But you'll notice that render describes how the UI looks at any point in time.
I can't help but call out the fact that he said that they created bindings for Backbone and Meteor so that you could use this and get the state from other more popular frameworks, all of which got killed and eaten by React.
So nowhere do we look in the DOM and find where we should update the count, or where that node lives, or we don't even set up a binding between the state variable and the DOM. And this is actually really simple because it's so declarative. Every place we display data is guaranteed to be up to date, and we do it without magical data binding.
If you started working on the web after React, you don't know how big a deal this was. It was so easy to have things in your UI that would not get updated even though the data changed. You would update a variable in the JavaScript and the UI would still show the old value because you forgot to create the binding to that element to update the text. If you forgot to do the button.text call here, or this number was rendered somewhere else as well, like let's say we took count and put it in 2 places instead of just in this button, but we forgot to update the other place that count exists, it's so easy to end up in a broken state with these types of things. Even if you just copy pasted this code, like I'll show you how easy it is to break this. So watch what happens. We have button 1 and 2. I click this, it increments button 1. What happens when I click this? Goes to 1, right? Nope. Goes to 13. Because we forgot to update the other element, and they're sharing count. So whichever was highest, when you click it, it's going to be the highest value plus 1 and never update properly. It's so easy to innocently make mistakes like this with jQuery. Hilariously easy, because the update of the count and the update of the component in the UI are 2 separate things. These being 2 separate steps you have to take doubles the likelihood you screw something up. I would say more than doubles, probably 10x's it. Because this is what you're thinking about when you're thinking about the logic. You're thinking about the count plus plus. You're updating the value. Then the UI has to be updated separately. If you remove the need to do that, the UI is a function of the state, in this case count. This whole abstraction can be removed and the entire class of bugs goes away. React has a different problem that's much less common and a little bit more annoying, which is things updating too aggressively, because any state change will trigger an update. It is basically impossible to get your React code into a bad state where the UI and the state logic don't match, because the UI is just the result of that state.
Without dirty checking the model, which can be expensive. And of course, this is a modern framework. There's no more explicit DOM operations, and everything is declarative. This seems like a pretty bad idea, right? It'd be great if we could do all this declarative work, but re-rendering all of the DOM nodes on your page is way too expensive. So we decided to build a virtual DOM to make re-rendering on every change fast.
I don't want this to become a virtual DOM video. If you've watched my other stuff, you hopefully understand how the VDOM works. I'd point you at a specific video, but I don't think I have one. It works well, though. The fun story I hinted at the beginning with Ryan Florence is actually, I don't know if this is something he has shared publicly, but we chatted about it. It doesn't seem like something he wants hidden. He used to be deep on the Ember world. The main reason he moved to React from Ember was performance. He had so many problems where they'd have like an input field that you would type and expect the UI to update. And if the UI updated from the input field, you would get the sticky keys feeling where you're typing and it freezes and you don't get all that data. Worst feeling ever. As long as you're not using a controlled input, React made that way, way better. And even if you were using a controlled input, it was still significantly better than alternatives at the time.
And we've built demos that run at 60 frames per second in non-JIT iPhone 5 web views. And that's the environment that a lot of PhoneGap users would use. The bottleneck is almost never the diffing. It's always the DOM operations.
Now our React apps have gotten so big, and we have so many elements in them that the diffing can also be a bottleneck. If you've seen React Scan, that's not checking how often is the web page content changing. It's checking how often is React double checking to see if it needs to re-render or not.
So the virtual DOM lets us do some other cool things. So we can run in Node.js.
This is also a big deal. This is why server rendering and like the whole server component arc we're on now could happen, because the virtual DOM as a layer can update the HTML on the page, but it can also render to string, where it actually outputs a string that you could then use to generate an HTML page. And the workings for that were there 11 years ago, before any of this was a thing they were actually building.
We're talking about not breaking the web in the last presentation. And I think there was mention of Google not crawling single-page applications that are all rendered in JavaScript. So what a lot of people are doing today is they're running Phantom.js, they're running their JavaScript, and then they're dumping a static HTML file and serving it to Google.
This is funny because that's actually what Remix was doing even like 3 years ago. But yeah, the classic spin it up with Puppeteer or something like that, save the HTML output, and then use that as your static page. That was the standard, and React kind of rethought that as well. It's a side tangent. It's way less important than the other things covered here, but it's cool that the groundwork was there day zero.
What we do is we can actually render an entirely static HTML page without a DOM on the server. So it's actually really, really fast, and you can serve all of your production traffic with it. So there's obvious SEO benefits here. But we can do some other cool things, too. You run the same code on the client and the server, and you send down some markup. React boots up on the client and looks to see if markup is there. If the markup is there, all it does is attach event listeners and initialize itself. So you get a faster page load experience.
I miss the days where like hydration was considered the faster option, which is kind of crazy because now people are like going insane saying hydration is the root of all evil and whatever. Funny enough, Mishko from the Angular side, now the Quick side, has made that the war he's fighting when previously it was the big benefit over something like Angular. It's just kind of crazy. I don't even know if they had the term hydration at the time.
Users will get the speed and of being able to interact with a static HTML page. And by the time the JavaScript is downloaded, the interactivity will pop in for you. So you could imagine the first page load experience is a static page. You start typing a comment in a comment box. And by the time you're done typing the comment and you press submit, the JavaScript is loaded in the background and you're ready to go. It's completely seamless. There's some other cool things we can do. Because you're building components that separate your concerns and represent your application structure, we have knowledge of what your application looks like and what it's going to do. So your components tend to reflect the structure of your application and the information architecture of the UI you're showing. So we can say, hey, if a large subset of this virtual representation is about to change, maybe we should use a different method of emptying DOM nodes than one for a smaller subset of the DOM.
This had another really big convenient benefit, which is previously, if you wanted to separate out the heavy JavaScript part from the pages that didn't need it, you would manually do that and make sure to include or not include the script tag on the pages that did or didn't need it. Since React doesn't have the weird bindings between everything and the component model is the root of everything, you can have a lazy component that only fetches its JS when it is rendered. That's so powerful. It means if we go back to like my diagram here, if you're in normal Twitch chat, you don't need any of the stuff here. So you can just not load this whole part. And then when subalerts renders, you can load it all then and not have to until then. That's so cool. That was not even kind of viable with these more blended MVC models. That level of separation would have to be done on every single one of these blocks by hand. And that's just gone now.
Render your interactive UIs. All in the same, you just create a component that renders to a canvas instead of to the DOM.
That was also a fun point. The you can just render to canvas instead became a whole different category of web applications and React 3 Fiber and whatnot. They let it run in a web worker. That ended up not being the right call. Let's hear the key takeaways.
Over the boundary into the web worker, and it sends DOM operations back over to the web worker. Like I said, not sure this is a great idea, but it has some cool implications. So let's talk about the key takeaways that I just mentioned. I want you to build components, not templates, because I want you to separate your concerns in the language of your application, not in the language of the framework.
The only template-focused thing that's gotten any traction since React started getting traction is HTMX. And even that's like an acknowledgement that your template doesn't do enough. We need more. Components, one, it's over. It's over. Components are the right way to structure our UIs. Even Apple built their whole new UI layer largely inspired by React. Swift UI is so close to React components. It's actually kind of funny.
It's really hard to think about mutation, so just throw out your old application, re-render the whole thing, and then have the implementation take care of it for you. And that implementation is a virtual DOM, and it's actually not very complicated and extremely fast, thanks to the great JavaScript engines we have today. So with that, I'd like to say thanks to JSConf for having me. That's it.
What a legend. I hope you guys can now understand why I thought this was worth dedicating a video to 11 years later. This isn't your normal talk. This isn't just a, hey, here's React and its features. This changed how we think about web development, if not development as a whole. The component model is something we're still learning from today, and I'm excited to see 10 years from now where we will be. Thank you to Pete, thank you to the React core team, and thank you to everyone who greenlit this and made it possible. The web that I know and love started with this talk, and I'm so excited to see where we go in the future. Until next time, peace, nerds. Trying to decide what's more tedious, dealing with someone who can't acknowledge React was wrong 20% of the time, or someone who can't acknowledge React was right 80% of the time. Then he followed up. It's pretty clearly the latter. I only need to be reminded of hypermedia web components and DHH.